Hello children, we are yet another session of Meet the NEET from Shankar Medico Academy. So today we are going to see an easy approach to solve numericals based on first order kinetic reactions. Okay, so I have displayed one question for you. The question reads, half-life of a substance following first order kinetics is 100 minutes. Starting with 20 grams of A, amount left after 300 minutes is, and they have given 4 choices. You have to choose from one among them. Okay, so basically, the T half for a first order reaction is 0.693 by K. Okay, where K is the first order rate constant. First order rate constant. Okay, so how do the students usually approach? They find out the rate constant using this equation, and then using this equation, (2.303 by T log of A by A minus X. And using this equation, they find out the amount left, that is A minus X. Okay, but proceeding through this involves cumbersome mathematical calculations. For example, you have logarithms involved. Okay, so you should finally take out the anti-log of these things. Okay, so the process becomes tedious. We will see into a easy way of solving this problem. So I'll write the equation for T half again. T half is equal to 0.693 by K, where K is the rate constant. Okay. Now, in this particular reaction, they have given the T half value as 100 minutes. Okay. And they are asking you what is the amount left after 300 minutes. Okay. So how do we approach this in an easy way? First, for the time T is equal to 300, we have to find out how many half-lives are there. So we can write this as 3 into 100 minutes. Okay. So we already know that 100 minutes is nothing but the T half. So this 100 minutes is having 3 T halves. 300 minutes is having 3 T halves. Okay. So it is now easy to solve the problem. Now, if we are going to take a sample containing 20 grams, after T half, what is the amount left? The amount left will be 10 grams because T half is defined as the time taken for the initial sample to become half. And for a first order reaction, the T half is independent of the initial concentration. Okay, so using that point, we can find out what is the T half if our sample was 10 grams. If the sample was 10 grams, the T half would be 5 grams. Okay, if the sample was 5 grams, then after a period of T half, the sample would be 2.5 grams. Okay, so I have used 3 T halves over here. At the end of 3 T halves, I have 2.5 grams of the sample that is left out. Okay, so the answer is 2.5. So by using this approach, we have we are not going through laborious mathematical calculations. Okay, and one point you have to keep in mind is this is applicable only to first order reaction. Such an approach is applicable only to first order reactions. Okay, so I believe this problem is easy to do. Okay, now we'll move on to the second problem. on similar lines. We are going to do it in this easy approach way. Okay, so the question is, the half-life of C14 is 5,760 years. Okay, so T half is 5,760. And for a 200 milligram sample of C14, the time taken to change to 25 milligrams. So what is the time taken to for the 200 milligram sample to become 25 milligram sample? That is the question. Okay. Now, this is an example for a radioactive decay. And radioactive decays, radioactive reactions are first order reactions. They are first order reactions. So we can use our easy approach route to solve this problem. Okay, so we will see how many half-lives are there, how many T halves are there, we will find out. Okay, then for a 200 milligram sample to become 100 milligram, it takes 1 T half. Okay, then for a 100 milligram to become 50 milligram, half of it, half of 100, 50, it takes another T half. Now, with another T half, the 50 milligram sample would become 25 milligram. Okay, so how many T halves are there for a sample from 200 milligram to become 25 milligram? There are 3 T halves. 3 T halves. Okay, so already the T half value is given for you. The T half value is given as 5760. Okay, so solving this, you will get this as the answer. 17280 years as the answer. So by proceeding through this approach, we have obviated the use of complex logarithmic calculations. Okay, so this is an easy way to do it. So moving on, I want you all children to do this as a exercise from your end. Okay, and I want you to post your answers in the comment section. Thank you.